Hi guys, welcome to today's tutorial. Today we'll be looking at finding logarithm using a mathematical table, and we'll be discussing how to find the log of a number using a mathematical table. Now it says the logarithm to base 10 are commonly called your common logs. Alright, now these common logs consist of the whole number aspect, which is referred to as the characteristics, and the decimal part, which is referred to as the mantissa. Now, characteristics is the power, of 10 to which the number is raised when put in standard form. Now, that simply means that if you have a figure and you're expressing that number in standard form, the number to which it is raised by 10, or the number of times the decimal point is being moved to form a standard form, all right, gives your characteristics. I take that again. The number of times your decimal point is being moved to put your number in a standard form forms the characteristics, while the mantissa, on the other hand, is derived from your four-figure or log table or mathematical table. Okay, your mantissa is derived from your mathematical table. Now, our steps in finding a log: first, we must express that number in a standard form. Now, if we express it in a standard form, the essence of expressing this in a standard form is to get our characteristics. Very, very important. Now, if we express it in a standard form, we determine our characteristics from there. Now, we find the mantissa of the given number from our log table. Okay, we find it from using a log table, and finally we would add the result from step 2 and step 3. So our characteristics plus the result, the number or the result gotten from our step 3, which is a mantissa, would form the log of that number. The next step we'll be looking at is, after finding that log, we will find the antilog of that result at the end of the day. So our first step is to express in standard form. Second, determine your characteristics. Third, find the mantissa. Fourth, add the characteristics and the mantissa together to give you the log of the number which you're looking for. And finally, we'll find the antilog of that number. All right, stick with us as we go right into examples. And if you haven't seen our videos on logarithm, do well to check the playlist for detailed videos on logarithm. All right, now our first set of questions says, find the logarithm of the following. We have 900, 1.25, 0.54, and 0.00054. Now, for the first one, let's look at the first one. We have 900, question 1. Now, our first step is to put this in standard form. And if you have to put it in standard form, it means that we are moving a point to be between the first and second non-zero digits. Now, in this case, in our 900, our first non-zero digit is 9. So that means our point, which is out here, will be moving 1, 2 to give us 9.0 times 10 raised power 2. Okay, now why is it 10 raised power 2? Because this point moved 1, 2 twice to move from here to get to this place. So this becomes 10 raised power 2. Now, our characteristics, to determine our characteristics, would be the power to which it is raised, which is 2. Okay, now our mantissa will be determined from our log table. Now, if we look at our log table, we are looking for log 90 under 0. Okay, so we are looking for log 90 because in our log table we do not have 9. Okay, since there is no 9 there, next value will be log 90. Okay, so looking at log 90 under 9 under 0, we are having it as 9542. So this would be 0.9542. Okay, since it's mantissa, 0.9542, 0.9542. All right, now having that, the next step says add characteristics and the mantissa. So our log of 900 would be 2.9542, having added this together. Okay, let's do it step by step. 2 plus 0.9542, which will give us 2.9542 as our log. So the log of 900 will be 2.9542. Now looking at our second question, which says 1.25. Now putting it in standard form, we have it as 1.25 times 10 raised power 0. Now why is it 0? Because our point is already between the first and second non-zero digits of our number. So it's not moving, it's not going anywhere, it's still at simple. So our characteristics will be 0. Characteristics would be 0, and mantissa would be 12 under 5. Now looking at our log table, we have 12 under 5 as 0.0969. Okay, 12 under 5, 0.0969. Now adding our log of 1.25 would be 0 plus 0.0969, which will now give us 0.0969 as the log of 1.25. Now to the third one, we have 0.54. Now putting this in standard form would give us 5.4 times 10 raised power minus 1. Now why is it minus 1? Now this is moving backwards. So since it's going backwards, it becomes minus. If it's going forward, it becomes positive. Okay? So now bearing in mind that this is our standard form, then our characteristics would be 54 under 0. Now 54 under 0 will give us 7324. Okay, so this becomes our characteristics is minus 1. Our mantissa would be 0.7324. Okay, now the next will be the log of adding them. Log of 0.54 would be minus 1 plus 0.7324. Okay, so this gives us minus 1.7324. All right, now having that as our answer, the fourth one will be 0.00054. Now we can write our number in standard form. Writing a number in standard form will be, all right, if you guess right, yes, 5.4 times 10 raised power minus 1, 2, 3, 4. Good. So our characteristics would be minus 4, right? So our mantissa would be still same, 0.7324. So the log of 0.00054 would be minus 4 plus 0.7324, which gives us minus 4.7324. Alright, now with this, we've been able to find the log of our numbers. In cases where we have answers as negative logs, we are using this as examples where we have negative logs divided by a positive. What do we do? Definitely, if we have this on our calculator, if we write this on our calculator, we are going to have a negative 0. And mathematically, there's no negative 0. Alright? So how do we solve this out to get our right answer? Okay, now, if we have this, we have about 1.5821 divided by 3. Now, in order to simplify this out for it to be divisible by 3, what we are going to do, we are going to find a catalyst. I do call it a catalyst, okay, to add to this equation to balance it, but yet it is not taking part in the calculation. So, like let's say a plus 2 minus 2 will give you 0, but it will help in balancing this equation. Now, we know that to get a 3, we are having a minus 1 minus 2, right? Minus 1 minus 2 will give us a minus 3. Now, if we add plus 2, this plus this cancels out, making 0.5821, all divided by 3. Now, we can see that if we add this up, this gives us a minus 3 plus 2.5821 all over 3. If we write this in a calculator, we'll still get a minus 1.5821. So it's like it's there, but it isn't there. So that's why I refer to it as a catalyst. So in this situation, we can now simply divide this equally. Now, 3 into 3 will give us a minus 1 plus 3 into 2, 0. Okay, 3 into 25 will give us 8. 8 times 3, 24. Okay, now carry 1. 3 into 18 will give us 6. Alright, 3 into 2 will be 0, and 3 into 21 will be 7. So when we add this up, we're having minus 1.8607 as our answer. Now you can see how we are able to divide this by our number. Now let's look at the second one, where we have minus 5.7384 divided by 4. Now if we have it as divided by 4, 5 can go 4 can go into 5, right? 4 can go into 5, okay, but in this case we are going to introduce a catalyst too. If we introduce a catalyst here, this becomes minus 5 plus 3, minus 5 minus 3 plus 3.7384 divided by 4. Okay, this is minus 8 plus 3 will give us minus 5. Alright, so here we are going to have it as minus 8 plus 3.7384 over 4. Now, 4 into 8 will give us about 2, and minus 2 plus, okay, 4 into 3, 0 points. Alright, now 4 into 37. 4 into 37 will give us 9, which is 36. Carry 1 into 13 will give us 12. That's 4 times 3, 12. Into 18 will give us 4 times 4, 16. That is 4. Into 14 will give us, into 24 will give us 6. Okay, so this, when we add it up, will become a minus 2.9346 as our answer. Minus 2.9346. So when you have a negative, you do well to find a catalyst or a number that when added will be equals 0, but yet help in simplifying your equations. Alright, looking at our next set of example, it says evaluate this and this, which is 5.049 divided by 0.1625 times 0.0572 all roots. And B says 4.078 raised to power 3 divided by root 6316. Now, in order to do this, we would have it as a number and log. Remember, our first number, which is a numerator, is 5.049. Okay? Now, since the point is not going to move, and changing it to standard form, this becomes our characteristic should be 0. Now, we are going to look for 50 under 4, difference of 9. 50 under 4 is 7024. 7024, difference of 9 gives us 8. That will be 7032. So this gives us 7032. Okay? Now, for this, our next number, which is 0.1625, putting it in standard form means we'll move this one place backward. So that will be bar 1.16 under 2, difference of 5. 16 under 2, difference of 5 will give us 2108. Okay? Now, the next one we are looking for is 0.0572. Now, changing this to standard form, we are moving our point backward. How many times? 1, 2. 2 times. So that gives us minus 2 over 2.57 under 2. 57 under 2 will give us 7574. Okay? Now, we add. Okay? Remember that this is a numerator. A numerator is going to be separate. 0.7032. We write it out. Okay? Now, we add our denominators. What are we having for denominators since we are adding? Okay? This becomes 8 plus 4 is 12. Write down 2. Carry 1. 1 plus 7, 8. This is 6. And this is 9. We have point. Now, minus 1 minus 2 will give us a minus 3. Now, bringing it out to a minus 3.9682. 9682. Now, since this is division, it becomes subtraction. Okay, so we are subtracting this from this. Now, 2 minus 2 would give us 0. Okay, 2 minus 2 will give us 0. Now, 3 minus 8 cannot, so we borrow from 7 and add to this. Okay, so if we borrow from 7 and add to 8, it becomes 13. This becomes 10. So we borrow to make it 9. So now 13 minus 8. 13 minus 8 would give us 5. Alright, now 9 minus 6 will give us 3. This is remaining 6. So we borrow 1. Okay, now 6 minus 6 minus 9 will give us 16 minus 9 will give us 7. Now, this is, we have minus 1, this is minus 1, here will be minus 1. So we have a minus 1 minus minus 3, which turns to plus. So 3 minus 1 will give us a 2. Okay, so our 3 minus 1 will give us 2. So this becomes 2. So now we have it as 2.7350. Now we look for antilog. Okay, sorry, before antilog, our root sign. So since this is all roots, it will be divided by 2. Okay, so when we divide it by 2, we would have an answer as 22 1.227 carry 1, 2213 6 carry 1, 2215 7 carry 1, 2210 5. Okay, now having this, we'll now find antilog of 0.3675. Okay, 0.3675, which will give us 0.3675 would give us an antilog of 2.331. 2.331. Okay, now times 10 raised for our characteristics here 1. Okay, either we leave it this way as 2.331 times 10 raised to power 1, or we can write it as 23.31 as our answer. Now, this is in standard form and this is in a normal form. Now, looking at our question B, okay, looking at question B, we have it as number and log. Okay, our first number is 4.078. Now, this is in standard form already, so our characteristics should be 0. Now, we are looking for 40 under 7, difference of 8. 40 under 7, difference of 8 will give us 6105. Okay, having it as 6105. Now, because of this 3, we'll multiply by 3. So this becomes times 3. Now, if we have it times 3, 6 times 5, 3 times 5, 15, rather than 5, carry 1. 3 times 0, 0, plus 1. 3 times 1, 3. 3 times 6, 18, rather than 8, carry 1. 3 times 0, 0, plus 1, 1. Okay, now this becomes a numerator when multiplied by 3. So let's write it out here as 1.8315. Okay. Now, going to our denominator, we have 6316. Now, putting this in standard form, we are going to move our points 1, 2, 3. So this becomes 3 points. Looking for a mantissa, you are looking at 63 under 1, difference of 6. 63 under 1, difference of 6 will give you 8004. Okay, 8004. Now, because it is root sign, square root sign, you will divide by 2. Since it is square root sign, we divide by 2. And if we divide by 2, we have it as 1.2231, 3 remainder 1, 2218, 9, remainder 0, into 0, 0 and 2. Okay, now because this is division here, we do what? We subtract this. So subtracting this, we have it as 5 minus 2 will give us 3. 1 minus 0, 1. 3 minus 0, 3. 8 minus 9, cannot, we borrow 1. 18 minus 9 will give us 9. So this is 0. 0 minus 1, okay, 0 minus 1 will give us a minus 1. Okay, so this becomes minus 1. So this we have as minus 1.9393. So now with this we can find the antilog of 0.9313. Okay, so we go to our antilog section of our log table. Okay, antilog section of our log table, we will have it as 8.537 8.537 as an antilog of this times 10 raised power minus 1. Okay, so this we can write as this, or 0.08, 0.8, since it's minus 1, 0.8537. We either write it this way or we can leave it at this form. Alright guys, with this we've come to the end of today's tutorial. If there are any questions, put them down at the comment section below. Don't forget to like, subscribe and click on the notification button to get more updates as we upload our topical questions and past questions on Logarithm. Thank you. See you in our next class.